So yesterday we have discussed about the collinearity and generalization, regularization, techniques like L1 and L2. May I know why do we require this? Why do we learning? Why are we learning these things? Do you think that we do have some challenges with the regular regression models, guys? Please do answer my questions, please. Do you feel that there are some challenges that we are facing due to the regression models? What do you mean by collinearity? All of you, what do you mean by collinearity? Okay, fine, leave it off. So coming to the regression models, let me just go ahead with my explanation itself. See, we have a problem of two different problems. One is underfitting and another one is overfitting. See, the regression models are not every time it is going to be a right fit with a proper high level of coefficient of determination, which makes you that you are writing a very great model by giving you a 95 percentage of R square value. So here, so why it is not fit? So what is the error between? So that error is none other than the bias and variance. What do we mean by bias and variance? See, if you can take a look at this one, you can identify three different diagrams in front of you. Okay. So the very first one, which is showing you the high bias and low variance. Okay. High bias means the distance between the points and why? Because the distance between the plotted points and the generated model, regression model, is having a high bias. Okay. Low variance. And whereas the in between it is going to be a good fit, and next one is going to be a low bias and the high variance. Okay, you can always define the bias in terms of a slope. Okay, in terms of the slope of the line defines here somewhere like a bias, and the variance, you could observe the variance, how the variance is looking like. Any one thing actually, high bias or the low variance, otherwise low bias or the high variance, this kind of tilting towards. Why? Because of this particular line. Okay, in the very first figure you can identify the distance between the point and the plotted regression line is having a lot of distance, and the sum of squares of error would be higher. So obviously that shows you a lot of bias. Okay, and you know uh, this is a low variance and high bias, or high variance and low bias. High variance represents there is a lot of tilting about the uh, variations in the line that I have drawn over here in the third figure. Okay, and low bias means there is no error here. Why? Because it is pointing out each and every point. It is circling out each and every point, and it is finally ended up. So it's a low bias and the high variance. See, this is not, see, the one where with the low bias and the high variance refers to the overfitting, and the one high bias and the low variance where refers to the underfitting. Why? Because the term overfitting refers only the one where you do have the low bias and the high variance. When you have the high variance, what happens? The test data will not fit into your diagram. Okay, only the training data will fit into the diagram, whereas the test data will not fit into the diagram. Coming to this underfitting, the training data itself is not going to fit. So there is no point in talking about this part even. So here the regression models are popular for making the predictions, whereas in that model we are finding some sort of difficulties in doing the best model. So if you can take a look at this one, the training data, we are trying to use data is a present data. Presently, whatever that we do have hold in our hands is the current data, and we will try to fit that model. Okay, but is that going to work with the test data which is going to come in the future? That is the problem. So the futuristic data, there is no if you are not, you will not get the right results if you have the bias under variance fluctuations. Okay, so that's why we need to try to fix the regression model or any other model without having such a kind of bias and variance fluctuations. For example, if you can take a look at this part, okay, there is a one particular line that you can see that here, the green in color is a regular regression line that I have drawn. Whereas with a little bit of slope, I have tilted. Okay, you can see the blue in color line. Okay, so where I have just given certain, slope, hence, the variance has been changed and the bias has been reduced. Okay, but that doesn't mean that it is going to be fit. So hence I have just little bit tilted backward and I have just gone a red colored line, okay, where it is trying to fit even for the futuristic data. So how do we come to know? There are the two different methods, something called a ridge regression and the lasso regression. And the elastic net regression is none other than the combination of ridge regression and the lasso regression. Okay. Okay, but the thing is, how do we understand? See, what is happening with the ridge regression, lasso regression over here, guys? Did you all understand till now so far here? Whatever that I have explained, all of you, the bias and the variance trade-offs, how they are influencing the models. Did you all understand, Suresh? That's really good. So now we need to understand in order to work with this ridge and lasso regression. Okay, what are all the things that we need to understand? What are all the things that we need to consider? So guys, we already know that what is the formula of the simple linear regression. See, whatever the regression model that we take into the consideration, y is equal to beta naught plus beta 1 x1. Let me say, for example, okay. And see, we can always go ahead and give a sigma, right? Hmm? Instead of sigma, I'm just writing e. Okay. So sigma, and we can generalize this one. Bi xi. Okay. Where sigma I is equal to 0 to n till n. Right. Can we write this one? Guys, we can write this one, right? So now, as a part of this one, why? Because this will be applicable for the multiple linear regression and the polynomial, whatever it is. But as a part of this one, we are going to take up something called a lambda. So I'm not able to show you that symbol of lambda. Okay, so hence I'm just trying to write down. I don't know the value of this lambda. Let us forget about this one. Even I don't know the value of this lambda at this point of time. So you just remember that it is a lambda into slope whole square. You don't know, like, even you need to apply the same sigma stuff. Understand? So you are going to make bi square. Okay. So b1, b2, how many you don't know even. So you need to apply the sigma over here again. Okay. So lambda whole square here, you're just squaring the slope. Okay. Squaring the slope. It means you are adding some sort of penalty. Okay, this is a one type which we will generally call it as ridge regression. Okay, what do you mean? Ridge regression. If at all, if you are going to make this happen in the same way with the modulus, instead of squaring this one, if you are going with a modulus, you're not squaring it, you're going with a modulus, then this is called as lasso. So what are the main advantages of using the ridge regression and the lasso regression? So guys, here, can you please tell me one thing? Why are we getting this kind of disturbances when we are working with the regression models? Can anyone tell me? I told you that there will be disturbances that we are getting, okay, when we are working with the data. Why are we getting those disturbances? Is that not just because of is that not just because of the multiple predictors which are highly correlated within themselves, right? When we have the multiple variables together, definitely there will be a chance of highly correlation between them, and the associated coefficients will be influencing the model. So those associated coefficients, shrinking of those coefficients deals with these ridge regression or lasso regression. And even while shrinking of the coefficients, ridge regression will not make any sort of feature selection, whereas the lasso regression will make the feature selection. Means, let me say, for example, in any of, let me say, like I do have the 5 predictors and one response. When I have the 5 predictors, out of which if I think that 2 predictors are no use, lasso regression will remove that, and lasso regression will make them 0. Ridge regression will not do something like that. It will just shrink the values of the coefficients in order to get the correct values. And next one is higher lambda values gradually shrink the coefficients to almost nearly 0. Okay. And the lambda values gradually reduce the coefficients exactly to 0, even for the lasso regression. And also there is a one more parameter that we need to consider, which is an alpha. Alpha, when the alpha is equal to 0, it will become a ridge regression. When the alpha is equal to 1, then it will become the lasso regression. Okay. For the models which are all overfitting, we will use the ridge regression. And for the models which are all the underfitting, we will use the lasso regression. Are you all good, guys? Why? Because this is a very important concept. Okay. Here at this point of time, uh, we need to understand the concept. If we don't understand the concept, there is no meaning of making out this part well. So here you need to ask the questions, and you need to let me explain you more about based on your questions. Why? Because once we cross this, we will be into the classification part. Once we complete the classification, clustering is not a big deal. It will just fade away within a day. Once after the clustering, we will jump on to the some of the modeling techniques, which will go in a couple of days, 1 or 2 days, and then we will be into NLP, and we will close by couple of model accuracy and neural network stuff. Understand? So the very most important things are regression models and the classification models, and the rest of them will follow these. That's it. I'm going to show you one program which will give you an awareness about the ridge regression, lasso regression, and elastic net regression. All these three things together. But before that, you should have to understand all these explanation, whatever that I have just gone through. So now you ask me the questions, whatever that you have got. Okay, someone is asking like how we can know alpha is 0 or 1. Suresh, okay. Ashok also asked me a question like, can you please explain once again how lambda values impacts here in underfitting and overfitting? Good question, Ashok. See, generally the lambda values are unknown. Okay, we doesn't know which lambda value will fit for the existing model. Hence, we will go for a cross validation across multiple values of the lambda. Hence, we will try to pick it up something, the best value of the lambda, where the at which value of the lambda the coefficients are getting decreased. Understand? Okay, and also coming to the lambda values and impact. We are not going to see the lambda value that we are going to pick up is something is between 0 and 1. Okay, when you have a, for example, let me say that's why I just wanted to have the higher lambda values represents here point not 1 is a lambda value. If I am going to multiply the same thing with the slope whole square, will I get the lesser value or not? Right? And I'm going to add the such kind of penalty to the existing model. Okay. So what is that doing is when I have the lesser in number of the lambda value, obviously it is shrinking the coefficients. So we cannot understand which lambda value will fit for the following regression model, whatever it is. Suresh, coming to your question, how can we know the alpha is 0 and 1? No, it is something, the alpha value is not something unknown. It is by default, alpha value is 0 for ridge regression, alpha value is 0 for lasso regression. Sunil is asking the question, difference between the coefficient. See, coefficient of determination will give you how well your regression model defines. Whereas the coefficient of correlation, it's not coefficient of correlation, it is a correlation. See, it is not a coefficient of correlation, guys. Okay. It's a correlation coefficient. It's a correlation coefficient is generally, I mean, you can talk however you want. Okay, so that is a relation between, it will give you the relation between the two variables. It is not about the regression model. If you wanted to talk about the regression model, it is a coefficient of determination. Okay, are you all good with my answers? Okay, we will do the program. Okay, why? Because it will not be, I don't have the sufficient time to go ahead with the program. Why? Because I don't want it to close the program even in a hurry way. We will have the program on Sunday then. Okay, I will schedule one session on Sunday, and we will close it. Then we can jump on to the classification part later. Okay, guys, are you all okay? Or if you or do you want me to go ahead with the program right now? I'm okay with that. I don't have any issues, but closing the program within a short time, I don't like it much. Okay. So hence I just wanted to go ahead only with that program and recap of all the regression models one more time. Hence we can close the complete regression models by Sunday, and then we can jump on to the classification and the rest of all the other models in the next week. Okay, see you all.